Okay, we can now proceed to calculus paper 1. Right, so in paper 1 under calculus they just bring two questions. Actually one. They bring one. It's either they'll bring a question on differentiation or they'll bring a question on integration. So make sure you know both. These are very simple topics. You just need to know them. In paper 2, that's when there's a lot of calculus. That's where there's a lot of calculus. You find they'll ask you to find either the equation of the normal to the curve, the equation of the curve, or the equation of the tangent, or the gradient of the curve. Alright, so I'm sure those from the main class remember to say we looked at a lot of calculus the time we were looking at cubic functions. Finding the gradient of the curve, there's differentiation there. Finding the area of the estimating the area bounded by the curve, there's integration there, where you have to use the upper and lower limits. And yeah, in paper 2 there's also that question on integration where you have the upper limit and lower limit given. Yeah, so paper 1 you just expect one of these. It's either you're going to look at a question on integration or differentiation. Then paper 2, that's why you're going to have a lot of those other questions that require you to use what you learn here. You just add on to what you have to look at in paper 2. Okay, so the first question is we're going to first begin by looking at differentiation, and then we're going to wind up with integration. So under calculus there's also a bit of indices, especially negative indices. All right, so it's important that we also know how to apply those concepts. Let me just try to correctly display this. So oops, don't even know what I did. Okay, let me try to move this to the back. Resize, crop, order. Okay, bring forward. Okay, how about this one? Let's try to crop it. Okay, looks like the dx was cut off. So how do you know that the question I'm dealing with is on, oh, you can't see what I'm doing here. Nice. Okay, so I'm just wondering what is this guy doing. Yeah, so apparently this recording software doesn't display the options and all that, so you don't see when I'm changing the color, bringing in a ruler or something. Does the ruler even show? I'm wondering, because the time we're looking at cubic functions and linear programming, I use the ruler a lot. Let me just see on my Google Meet if it's showing. Ah, great. It's good to know that it was showing in the previous sessions. Otherwise I was going to worry. So obviously people are wondering what ruler is he talking about. Anyway, so how do you know that the question you're dealing with is on differentiation? How do you know that this one is on integration? So for differentiation, they will sometimes say differentiate, like you can see this question right here. Differentiate y 1/3x cubed minus 5x squared minus 2x with respect to x. Sometimes they'll say that, or they'll simply say given that y is equal to 2, 3, they give you a function, and then they'll say find dy over dx. Whenever you just see dy over dx, just know that this is differentiation. Integration, they'll either say integrate, you will solve these questions, all of them with respect to x, or they'll say find, they'll give you a function inside the brackets, and then there's this symbol that looks like an s. So this is the integral symbol. Whenever you see this symbol, just know I'm integrating. Sometimes they'll say find the integral of something with respect to x. So whenever you see the word integral, integrate, and this symbol, just know that I'm integrating. Whenever you see dy dx at the end, this is simply because the question is on differentiation. So now, how do you differentiate? Okay, so when you are differentiating, you simply multiply the power of x. Let me write something here. So the equation is y is equal to 2x cubed minus 5x squared plus 4x plus a 2. So to differentiate, you get the power of x, in this case 3, multiply it with the coefficient of x, which in this case is a 2, and then you reduce the power by 1. You take away 1 from the power of x, so meaning it's going to be 3 times 2 to the power x, to 3 times 2 x to the power 3 minus 1. That's how you differentiate. Multiply the power of x with the coefficient of x, and then you take away a 1 from the power of x. So always make sure that you get the power of x with its appropriate sign. So here the power is a positive, so the first thing is you're going to replace this y with dy over dx. This shows that you are differentiating. We said multiply the power of x with the coefficient of x, so we're going to say 3 times 2, then you say x to the power 3 again. Then you're supposed to take away a 1 from the power of x, so we're going to say minus 1 there. Okay, here what is the power of x? It is a positive 2, so we're going to say plus 2, okay, times the coefficient of x here is negative 5, so we're going to say negative 5 close bracket x to the power 2, this x to the power 2 there, and then we're supposed to take away a 1 from that one. Okay, then we can say plus, let me move the screen to the right. Okay, that should be enough. Okay, and then plus, we have 4x here. What is the power of x? It is a 1. Remember we said if you can't see the power, then it's a 1. The time we're looking at integers, indices actually. Yeah, or if you don't know, for those that are new here, when you don't see the power, it simply means it's a 1. So we're going to say 1 times 4, positive 1 times 4. 4 is a coefficient of x, and then we take away a 1 from the power of x, plus we have a constant there. Whenever you are differentiating a constant, you need to add an x and raise it to the power of 0. So meaning this one is going to become x to the power of 0. Whenever you are integrating or differentiating a constant, you add an x, raise it to the power of 0. So here, what is our power here? The power of x is a 0. So we are going to say 0 times the coefficient of x is a 2, x, okay. So let's push it to the right again. Okay, x to the power, what do you get? X to the power 0 minus 1. Remember, you're taking away a 1 from every single power. Once you've done that, you start simplifying. So I'm going to say dy over dx will be equal to 3 times 2 there gives us a 6, x to the power 3 minus 1 there gives us a 2. Okay, then here we're going to say 2 times negative 5, positive 2 times negative 5 will give us negative 10, x to the power 2 minus 1 will give us a 1 there, 1 times 4 there will give us a positive 4, x to the power of 0, because 1 minus 1 is a 0. Okay, then here we're going to say plus 0 times 2, that will give us 0 x to the power negative 1. Okay, 0 times x to the power negative 1 there will just get 0. Therefore the shortcut is whenever you're differentiating a constant, it becomes a 0, because you've noticed here we've expressed this, when you multiply there, you simplify, your final answer will just be a 0. Okay, that is the shortcut. So in the next questions, whenever you're differentiating a constant, will just be converting it to a 0, now that you know the process of how it becomes a 0. Another one is basically going to be this one here. Let us solve so that we can see how that one is going to change. So dy over dx, here we have 6x squared minus 10x. Remember we said when the power of x is a 1, there is no need for you to write it, plus 4 times any value raised to the power of 0 is a what? A 1. Okay, so dy over dx will be equal to 6x squared minus 10x plus 4. 4 times 1 is a 4. So here is a shortcut. Whenever you are differentiating a value whose value of x is 1, okay, your final answer is just going to be 3. You've noticed here there was 4x right here, 4x. What is your final answer? That. So whenever x is raised to the power of 1, you know to say it's going to subtract 1 minus 1 will give you where is that? Where was that? here there 1 minus 1 becomes a 0, converts to a 1, multiplies with a coefficient which gives you a 1. So those are some checks and balances you can do as you are differentiating. That's how come sometimes I can look at a question and be able to figure out the answer. Okay, for example, this one here, I know to say 3 times 2 is 6x minus 2, that would be 6x squared. This one will be negative 10x. This one will just be 4. This one I know will convert to a 0. So this is therefore going to be our final answer. Do you have any questions? This was some form of an introduction. The next questions will be cruising a little bit faster. So are we all clear here? Are we good to proceed to the next questions? Okay. All right. Let's now progress to the next question. The next question says, given that y is equal to 2x cubed minus 4x squared, find dy over dx. We said whenever you see dy over dx, it simply means you're integrating. So first you write down the equation or function 2x cubed minus 4 over x squared. So now, before you start differentiating, you need to convert all powers to negative indices. This here is a positive index. Now convert it to a negative index. Remember, okay, if you don't know, this is what happens. Any value raised to the power of a negative power simply becomes, this negative means 1 over the 2 comes down here and the power follows the 2. So it's going to become a 3 there. You can now see to say this negative power has been converted to a positive power. How about when you have 3x squared? What's it going to become? We said this negative means 1 over. So the easiest way you can understand this is by separating these values. You're going to say 3 times x to the power negative 2. Because the negative power is only for x. The power of 3 is a 1 here. Okay, we said this negative means 1 over. So we're going to say 3 times 1 over, the base goes down here and then the power follows the base. When you multiply, you're going to say over 1, 3 times 1 is a 3, over 1 times x squared is x squared. This is similar to what you have there. So now we need to bring it back to its original version, which is what you have there. So what is the easiest way to do that? The easiest way to do that is simply, this is what we have. Let's say 3, let's use this example. 3 over x squared. All you have to do is you write your 3, your base goes upwards, and then the power becomes a negative. That's how you do that. Meaning, here we're going to say dy over dx is going to be equal to 2x cubed minus 4, the x goes up there and then its power converts to a negative. That's how you express positive indices as negative indices. Once you have done that, you can now start differentiating. Remember we said to differentiate, you need to multiply the power of x with the coefficient of x. So dy over dx is equal to 3 times 2 there, so that's 3 times 2 x to the power 3, take away a 1. Here your power is a negative, so meaning we're going to say minus 2 times negative 4 x to the power negative 2 minus a 1. Okay, let's move to the right. Where is this cursor? Okay, power negative 2 minus a 1. So meaning dy over dx will be equal to 3 times 2 there will give us a 6, x to the power 2, because 3 minus 1 is a 2. Negative here times the negative there gives us a positive. 2 times 4 is 8, x to the power negative 3. Okay, negative 2 minus 1. When the signs are the same, keep the same sign, you add. Okay, we're done differentiating, but your final answer should be expressed using positive indices. So this 6x, this 8x to the power negative 3, we need to express it as a positive index. So how do you do that? The easiest is simply say 8, your x goes down here as your denominator, and then the power becomes a positive, just like we did with the one up there. So your final answer should be expressed like this, not like this. You only do this when you want to differentiate or integrate. The final answer, you need to convert it to this one. So the easiest is maintain the coefficient, the x becomes a denominator and its power becomes a positive. Okay, to do the opposite, you simply add the x here and then its power becomes a negative. So that is that about these types of questions. Is it clear? Is it clear? I can't see any responses. Are people understanding? Hello, are you with me? Okay, great. Please respond whenever I ask for a response. Okay, looks like I made a mistake and deleted some of the questions. Let me just try to bring them back. So okay, so I made a mistake and deleted some questions on integration. Let me just quickly add them back. Okay, let me just check my folder. Okay, so there's this other interesting question that I would like us to look at. Very interesting question. I remember giving it to my students last year and they had issues with this question. Okay, I think that'll be our last question on differentiation. We now go to integration, which is going to be, we're going to start with this one. Let me crop out the question on quadratic equations here. Okay, what else do we have? Okay, we have this one. And what else? Okay, so I have this one here. Okay, looks like we are all good now. All right, so we are now proceeding to this one, which says differentiate y is equal to 1 over 3 x cubed. So here our coefficient of x is a fraction. Y is equal to 1 over 3 x to the power 3 minus 5x squared minus 2x. Remember I said whenever differentiating a value with whose x power is a 1, the x just disappears. Okay, so to differentiate, we're going to say dy over dx. So now here, your coefficient of x is a fraction. So that 3 should multiply with the entire fraction. So it's supposed to be 3 times 1 over 3 x to the power 3 minus a 1. Alright, that is how it's supposed to be. Your 3, remember, is multiplying with a coefficient of x. In that case, your coefficient of x is a fraction, so it must multiply with a fraction. Okay, and then we're going to say minus, not really minus, the power is a positive here, so we're going to say plus 2 times negative 5 x the power 2 minus 1. Okay, here the power of x is 1, so I'm just going to say plus 1 times negative 2 x the power 1 minus 1. So meaning dy over dx will be equal to, so that 3 and that 3 can cancel. You're just going to remain with x, or 1x if you like, the power 2, because 3 minus 1 is a 2. And then you're going to say positive times this negative there will give you a negative. 2 times 5 is a 10. Okay, 10x the power 1, because 2 minus 1 is a 1. Again, positive times this negative there is a negative 2x the power of 0. So finally your answer will be dy over dx will be equal to x squared minus 10x minus a 2. Remember, any value raised to the power of 0 is 1. 1 times this 2 here will give you a 2. And you are done. As simple as that. Remember the drill. If you have a question, you can write in the chat or raise your hand. Okay, that is how we do that one. So we are done with integration, differentiation. Now we look at integration. So integration is basically the opposite of differentiation. The time we are differentiating, we are multiplying the coefficient of x with the power of x. In this case, we are going to be dividing the powers of x with the coefficient of x. So the question says integrate 3x to the power 4 minus 4x to the power negative 3. So the first thing you do here is you plug in the integral symbol, the one that looks like an S, this symbol right there. And then you're going to open the brackets, and then you're going to say 3 to the power x. Remember, every time we're differentiating, we're subtracting 1 from the power. When you're integrating, you add a 1. And then this expression you have up here is going to be what? Your denominator, like that. So if you have 4 plus 1 up here, even down here you're supposed to have 4 plus 1. Then we're going to say minus 4x to the power negative 3, we add a 1, over negative 3 plus a 1. Okay, once you do that, you now need to add a c. Okay, add the constant c inside the brackets. So always remember to add this guy, the c. Then you can go ahead and simplify. So I'm now going to say 3x to the power 4 plus 1 gives us a 5 there, over a 5 down here. You're adding the same values here and there, therefore your values shouldn't be different. Okay, then you're going to say minus 4x, there's supposed to be an x here, the power negative 3 plus 1. Okay, so negative 3 plus 1 will give us negative 2, over there we're going to have negative 2 as well. Then we're going to say plus c. So now for your final answer, remember we said on your final answer, avoid having negative indices. A power that is a negative, you need to convert it to a positive. So to convert this one to a positive, remember the x was going downwards and then the power becomes a positive, right? So at this point, actually we can divide the signs. This negative here divided by this negative here will give us a positive there. Okay, and then we can actually simplify, not just divide the signs. Okay, minus minus. Okay, we can say negative divided by the negative there, giving us a positive here. Then we can say 4 divided by 2. This 4 divided by the 2 there gives us a 2x to the power negative 2 plus a c. So we now need to express the other value as a positive power. Okay, so we're going to say integral of 3 to the power x, 3x to the power 5 over a 5 plus 2. Remember we said the x becomes a denominator and its power becomes a positive, plus c. That will be your final answer and you are done. I hope that is clear. Okay, we proceed to the next question. So the next question is this one. Find, remember we said whenever you see this symbol, simply means integration. So I'm going to say 3x squared plus 8x minus a 5, like that. Okay, so to integrate we add a 1 to the power of x. So I'm going to say 3 x 2 plus 1 over 2 plus 1 plus 8 x to the power 1 plus 1 over 1 plus 1. Alright, and then there we said whenever you're integrating a constant, you need to add an x raised to the power of 0. So I'm going to say 0 plus 1. So when you're integrating or differentiating, it's the same process. Whenever you're dealing with a constant, raise it to the power of x, add an x and raise it to the power of 0. So therefore it becomes 0 plus 1. Over here we're also going to have 0 plus 1, and then you remember to add the constant. Okay, so your final, not really your final, let's see how this goes. We're going to say 3x to the power 2 plus 1 there will give us a 3, everything over a 3 there. Okay, plus 8x squared, because 1 plus 1 there is 2, over a 2 there, minus 5x to the power of 1 over a 1 plus a c there, you close. So you can simplify some values there. We're now going to say integral, the 3's will cancel there, will just remain with x cubed, plus 8 divided by 4 by 2 is a 4, so I have 4x squared there, minus 5 divided by 1 is a 5, raised to the power of x raised to the power of 1. But when the power of the value is a 1, you don't write it. So that will be your final answer, and you are done. Is that clear? Do you have any questions? Okay, we go to the last question, which is saying find the integral of 3x cubed. So this one is a bit blurry. Let me just copy it down for you. So this one says 3x cubed over 2 minus 5x plus 1 over x squared. We're asked to find the integral, so we know we are supposed to integrate. So allow me to just do this right here and put these in brackets. So now remember, you are dividing the coefficient of x with the power of x. So in other words, what's going to happen is you're going to say 3 over 2, okay, times x to the power 3 plus 1. Remember, you're adding a plus 1 to the power of x, and then you divide this with 3 plus 1. You are dividing the coefficient of x with the values you have up there. So that is basically how we're going to do it. Then we're going to say minus 5x1 plus 1 over 1 plus 1. And then the second one, you are going to convert it to a negative index, right? So we said the x goes up and then its power becomes a negative. So it's the same as x to the power negative 2, then we can add a 1 to integrate. Even here we're going to say negative 2 plus 1, and then you say plus c, you close. Okay, we now move it to the right. Like that. Okay, so just take it step by step. The examiner infused fractions here as constants so that they can confuse us, but we're going to do it step by step until we get it right. So this side we're going to have 3 over 2 x to the power 4, because 3 plus 1 is a 4, and then divided by a 4 there. Okay, minus 5x, 1 plus 1 is a 2 there, over a 2, and then plus x to the power negative 1, because negative 2 plus 1 is a negative 1. Down here also going to have negative 1, then you say plus c. Okay, so now there's this part we need to simplify. Alright, so now how are we going to do that? We can easily understand this by doing it this way. We're going to say 3 over 2 divided by what? By a 4. How do you simplify a fraction? So you can say over 1, and then you apply the KCF, keep change flip. So you keep the first fraction the way it is, which is going to be 3 over a 2, change that to multiplication, and then that will change to 1 over 4 instead of 4 over 1. Okay, once you do that, you can now multiply. 3 times 1 will give you 3, 2 times that will give you 8. I hope that is clear, because this is 3 over 2 divided by 4, which is what I have done by expressing it that way. Then we apply the keep change flip. On the right we flip the sign, we change it to multiplication, then you multiply numerator times numerator, denominator times denominator. 3 times 1 is 3, 2 times that is going to give us 8. So meaning, what are we going to have? We are going to have 3 over 8 as our coefficient here. 3 over 8 x to the power 4 minus, okay, 5 over 2 x squared. Alright, then you're going to divide the signs here. Negative divided by positive is a negative, x to the power of negative 1, and then you're going to say plus c, you close. The last thing, you need to express that that x to the power negative 1 as a positive index. So I'm just going to say minus 5 over 2 x to the power 2 minus a 1 over x, okay, plus a c. Remember we said the x goes down, so since there is no coefficient, there is no visible coefficient, remember the coefficient of x here is a 1, so that's the one you are seeing down here. The x goes down and its power becomes a positive. Okay, it's supposed to be positive 1 there, but we said when the power of a value is 1, you don't write it. So that is what we're going to have as our final answer right there. Is that clear? Have we understood? At this point, we are ready for any question on calculus in paper 1. Paper 2 will just be an extension of this, what you have looked at here. Is that clear? Have we all understood? If you have understood, please respond with a thumbs up. That will show me that people have understood. I'm still waiting for feedback. Have people understood? This was our last question on integration. Okay, great. I've seen some responses. Have we all understood? How about the others? Mr. Emmanuel, are we good on integration? Okay, great. All right, so like I earlier mentioned, I'm not feeling too well tonight. I also feel this is going to help those that have network problems. Initially, we're also supposed to look at coordinate geometry, but because I'm not feeling too well, we're going to schedule another day during the week to cover this one, probably Monday. Yeah, we'll cover this one on Monday. Coordinate geometry is quite lengthy, so I wouldn't want to rush through it simply because I'm not feeling too well tonight. Yeah, also on coordinate geometry, we're also going to fuse in calculus. I couldn't bring in other questions like these. For example, let me just show you something. These are types of questions which fall under calculus. They are a combination of both calculus and coordinate geometry. So we couldn't look at those questions because we've not done coordinate geometry. Remember, we're taking it that not all of us have done coordinate geometry. So it would be unfair for me to start looking at these questions when there could be someone who hasn't done coordinate geometry yet. So these types of questions come in paper 2. Okay. So we'll look at these ones. The time we'll be looking at coordinate geometry. Okay, so let me just add this last one. Actually, there is another one I can add, which is this one. These are the questions I intend for us to cover as a bonus. We're looking at paper 1, but we can also look at these since they fall under calculus. So the first one, we are asked to find the equation of the normal to the curve. Y is equal to x squared plus x plus 2 at the point 1, 4. So to solve this question, all we have to do is differentiate this equation of the curve. Okay, once we differentiate it, we're going to find the gradient function. Okay, in that gradient function, where there's x, you put the x coordinate, which is a 1. Okay, then you can go ahead and use the properties of equation of a straight line to find that equation. So this may sound strange to people who have not yet done coordinate geometry. That is why I've decided not to cover this tonight, because there's a topic that needs to be done first before you can come to this one. Find the equation of the tangent. Same thing. Oh, the normal, actually you use a different way to find the gradient. You're going to use the properties of perpendicular lines, which falls under coordinate geometry. Find the equation of the tangent. First, same process. Differentiate, find the gradient, and then use the formula for finding the equation of a straight line to find the equation of the tangent. Determine the equation of the normal to the curve, same as what you had up here. So this was 2024, this was 2018, and then this was 2021. The next one, so we also have this question on integration, where you have the upper limit and lower limit. Also cover that one during that session. This one says determine the equation of the normal to the curve. Normal to the curve, again, 2018 paper 2 GCE. So in 2018, this should be the same question. I think I plugged it in twice, yeah. And then finally 2017 paper 2 GCE, find the equation of the tangent. So these questions always come in paper 2. So remember what we said, now is not the time for us to be shooting everywhere. Pick your questions, perfect. So once we know how to find the equation of the tangent, the equation of the normal to the curve, and the equation of the curve, we are good for any of these questions, because we know one of these is coming. So we would do well to prepare for any of these. How do you prepare? You don't know what's coming, so you have to know all three. How to find the equation of the tangent, how to find the equation of the normal to the curve, how to find the equation of the curve itself. I think I didn't capture this question, but I'll make sure I capture it in the next session. So that is all you have to do in mathematics. Pick your questions, hammer them mercilessly. Okay, make sure you know how to answer any version of that particular question, because you know this one is coming no matter what. That's why paper 2 is very simple, because you can actually predict what's coming. It's different from paper 1. Okay, although if you are smart enough, you can also figure out what questions always come in paper 1, and then you make sure you hammer all versions of that particular question, meaning you can handle anything they will bring. So we'll probably do this on Monday, yeah, because on Monday I don't have a live session at night. Yeah, so so far we have covered about 3 sessions. On last week we covered 104, which had algebra, indices, arithmetic progression, functions, variation, quadratic equations, and in this session we've covered 2, which is calculus and area of a sector. On Monday we'll wind up with this one, but on Sunday we're doing these, okay, on the right. So on Sunday at 14 hours, the time is different for Sunday. 14 hours we'll do matrices, earth geometry, inequalities, and speed time graph. So if you're interested, you can also sign up for these. All right, yeah. So otherwise that is all I had for you in this session. I'll communicate when exactly we'll do coordinate geometry, but most likely Monday. I'm sure by Monday I'll be much better. Actually by tomorrow I should be much better to be able to do this one. Okay, otherwise thank you for your time, ladies and gentlemen. Enjoy the rest of your evening.